Okay, in this video we're going to begin section 8.3, which is graphing linear equations, and then also graphing absolute value functions. So before we get to graphing stuff, of course, hopefully at some point you've done some graphing. Like, you should be expected to be familiar with the coordinate system, that is the XY axes, the four quadrants, plotting points, maybe drawing a simple curve, okay, like a line or something. We're going to build on some of that here. So problem 7, determine if the point 3, -4 is on the graph 4x minus y equal 8. Okay, so in this problem, x is 3 and y is -4. So if you plug in those numbers here, would you get a true statement? Well, I've done that. Okay, x is 3, y is -4. 12 plus 4 is not 8. So no, this point would not be on the graph. Okay, determine 3 points that would be on the graph of this equation. Well, there's infinitely many points that you could list, but like if x is 3 and y is 4, 12 minus 4 is 8, that'd be true. If x is 2 and y is 0, 8 minus 0 is 8, that's true. And then if x is 0 and y is -8, 0 minus -8 or 0 plus 8 would be 8, that's true. There's, of course, many points that I could list here. Now, the 2 points, 2, 0, and 0, -8, are special points that are called intercepts. I'm going to talk about that next here. An intercept is a point where a graph crosses the coordinate axis, or crosses or touches the coordinate axes. An x-intercept is an x value where the graph crosses or touches the x-axis, and then a y-intercept is a y value where the graph crosses or touches the y-axis. So let's take a look at problem 9. We want to determine the intercepts for the equation 4x minus y equal 8. And then we'll graph this line. Okay, so I've got two columns set up here, one for the x-intercepts, one for the y-intercepts. That's how you'll want to do it in general. Okay, but to find an x-intercept, you're going to let y be 0 and solve for x. To find a y-intercept, you're going to let x be 0 and solve for y. So whatever type of intercept you're wanting to find, let the other guy be 0 and then solve for that variable. All right, so here, when I find the x-intercepts, I'm going to let y be 0 and solve for x. If y is 0, 4x equal 8 divided by 4, that means that x is 2. Okay, so 2, 0, well, that's a point that I had found here by just guessing and checking, but that's actually the x-intercept. To get the y-intercept, you're going to let x be 0 and solve for y. So when x is 0, you're going to have negative y equal 8, or y equal -8. 0, -8 would be another intercept. That's our y-intercept. Okay. So then the next thing I'm going to do is I'm going to set up a graph here, and I'll plot these 2 points. Here's 2, 0 on the x-axis, and then 0, -8 on the y-axis. I'm drawing a line, and so using these 2 points, I can then draw on the line. Okay. Now, of course, I could plot more additional points. There's infinitely many points that would be on this line. Of course, the more the better. But we found 2 key points on this line, the intercepts. Okay, now in this section also we're going to talk about linear functions. Before we talk about that type of function, definition of function is a rule that takes an input value and assigns one and only one, that's keywords here, output value to it. The domain of a function is the set of all input values, and the range of a function is the set of all output values. Okay, so let's take a look at problem 10. Determine if each relation below is a function. A relation is just a correspondence between two things. Okay. If it is a function, state the domain and range. If it is not, explain why not. Okay, so in part A, do we have a function? So does each input go to one and only one output? Yeah, so each daughter is going to have only one mother. Nobody can have 2 different mothers. That's not possible. Okay, biological. So each daughter, each person in general, is going to only have one biological mother, which means that this is a function. Okay? The input values would be the names that are the daughters here, and then the output would be the names that are the mothers listed. The domain is the set of all the input values. Now, set is a key word there, so I want to make sure I'm using set bracket notation when I list the items in the domain, and I would just be listing the names that I see here that are the daughters. The range is also a set as the set of all output values. So again, I want to make sure I'm using set bracket notation, and I would just list the names that I see that are the mothers listed. Part B, okay, do we have a function here? No. For each input, there is not only one output, okay? Rosie has 2 sons, okay? A person can have more than one son, right? So we're not going to have a function since each input does not go to exactly one output, okay? And I would also add that any situation that looks like the one that you see here, where you have an x value going to 2 different y values, it's not a function. One way to think of this is that if you have a person standing on the left side of this diagram and going to walk over to the other side, that person can't be in 2 places at one time. That's not possible. So here's, specifically you're looking for that situation where you have an x going to 2 different y's. Now it is okay to have 2 different x's going to 1 y. That is possible. We saw that over here. That's still a function. But you can't have an x going to 2 different y's. Problem 11, determine if the set of ordered pairs is a function. It's not going to be a function here because of these 2 points listed, 5, 3, and 5, negative 2. 5 is going to 2 different places. 5 is going to 3, and 5 is going to negative 2. And we just said for each x, there's only one y, not 2 different y's. And so I've got that stated there. Okay, now a linear function is a function of the form f of x equal mx plus b. Okay, you've probably heard of y equal mx plus b, which is the slope-intercept form of an equation of a line. Y and f of x mean the same thing. Okay, you're talking about what's coming out of the calculation. Here's the function notation. F of x is how we'd read that. Okay, and we're going to do some things more with functions in chapter 11. Of course, they kind of mix in some things with functions beforehand, and they've already talked about functions earlier in the book, so it's kind of more a review, and then we'll go a little bit deeper as we bring up the idea of functions again. Graphing a linear function is the same as graphing a line, y equal mx plus b. M is the slope of the line, and b is the y-intercept for the line. So the y-intercept, again, is the point where the line is going to cross the y-axis. Okay, so here's an example. We want to graph the line f of x equal negative 3 halves x plus 6 using the slope and the y-intercept. We're going to determine the intercepts also, both of them. But all right, so if we use the slope and y-intercept method, the slope is negative 3 halves and the y-intercept is 6. So I can begin graphing this line by plotting the point 0, 6, where it's going to cross the y-axis, and then work off of the slope. The slope is negative 3 halves. You've probably heard of the terminology rise over run. Rise over run is terminology that we sometimes use to describe the movement from one point to the next. Okay, you're going to rise up so many units from your first point, and you're going to run either to the left or to the right to get to that next point. In general, you're going to run to the left if the slope is a negative, and you'll run to the right if the slope is a positive. So here I've got a negative slope, which means I want to be going to the left after I've risen so many units. So I'm going to rise 3 units and go to the left 2. Rise 3, go to the left 2. Rise 3, go to the left 2. Okay. Now rising 3 and going to the left 2 is the same as going down 3 into the right 2. If I go down 3 into the right 2, I'm using this, the same idea. I'm just gathering up some points flowing in the other direction here. So then once I have a couple of points, I can then draw on this line. Another option for graphing the line is to use the intercept method, okay? So if we find the x and y intercepts, we can then plot those points and then draw the line. To find an x-intercept, you're going to let y be 0 and solve for x. Y and f of x mean the same thing, so when I say let y be 0, I mean let the function be 0 and solve for x. Okay, and then, so I've done that, let y be 0. I'm going to add 3/2 x to both sides, and then if you multiply by 2 and divide by 3, we get x equal 4. So 4 is 0 would be my x-intercept. The y-intercepts are found by letting x be 0 and solving for y. So when x is 0, I would just simply plug 0 into the function, and I'd get 6 in return. So y is 6 when x is 0, which means that 0, 6 is on the graph. Now I already knew that because 6 is my b value here, or my y-intercept, just because of the form that this was written in. So I've got my two intercepts plotted, these 2 points, and I could have, I could draw the line that way. Now, ultimately, I don't care how you draw a line. Just make sure that you've drawn the line correctly. A line is the most basic curve that we'll be, ever working with here. And we have to be good with lines. Okay, if we're not good with lines, that could be a real problem with looking at how other curves are, behaving with, with twisting and turning and looping all around and doing a bunch of weird stuff. Okay, so that can be problematic down the road if we don't have the idea of a line set. So let's take a look at problem 13 next. We want to graph the line y equals 5x minus 3 using the slope and the y-intercept. And then we'll use the intercept approach just to, kind of tie this in. There's a couple of problems in the book where they want you to graph using the slope and the y-intercept, and then there's a couple where they're wanting you to just graph using the intercepts. Again, I don't care what method you use, just make sure that you've drawn the line correctly is all. So this line has a slope of 5 and a y-intercept at -3. So I can start right here on the y-axis at 0, -3, and then use the slope. Now 5 is the same as 5 over 1. Okay, so think rise over run. I need to go up 5 and to the right 1. Well, that's going to bring me to this point here, 1, 2. And I could continue to go up 5 and to the right 1, up 5 and to the right 1. Okay, and gather up a whole bunch of points on this line. Notice how this line is slanted in the positive direction. That's because we got a positive slope. In general, a line that has a positive slope is going to be slanted in this direction. A line that has a negative slope, like we saw in the last one, is going to be slanted the other way. Now, how I like to remember this is that a line that has a negative slope on it means that you can construct a capital N for negative, okay, whereas you can't do that with the positive case, right? So the slope, really, really important, okay? Not only does it tell us which way the line is going to be slanted ahead of time before we even do anything, but it also tells us how to get from one point to the next on the line. It tells us how to build the line is what's key there. Okay, and if we wanted to use the intercept approach instead, I got to get my x and y intercepts. As long as the 2 points that are the intercepts are somewhat distant from each other, that's a great option for drawing a line. If we let y be 0 and solve for x, add 3 and divide by 5, I'm getting x equal 3/5 0. So that would be this point here on the x-axis, 3/5 0. And then if x is 0, and we find y, again, y and f of x mean the same thing. Now I'm not using function notation here, but I was in the other problem. Okay, y and f of x mean the same thing. If you let x be 0, you're going to have y equal -3. So 0, -3 would be where the line crosses the y-axis. Now, and again, we already knew that because the b value is -3, right? And that's how I drew this line initially, by working off of the slope and the y-intercept. And I'll go ahead and stop the video right here.